In January 2005, NASA launched a unique space probe, its mission, to find out where did Earth's water come from. The probe, named Deep Impact, traveled 270 million kilometers until it finally reached a comet. And inside that comet were secrets, ancient secrets, secrets humanity had been searching for centuries. Welcome back once again to Very News Video, dear viewers. In this entire universe, there's only one known place where human beings can survive. It almost feels as if Earth was made just for us. Here we have everything essential for life: water, food, and oxygen. In this vast, giant universe, maybe there's another planet like Earth, or maybe not. But for now, Earth is the only place we know where humans can live without any external support. But 5 billion years ago, Earth didn't even exist. The very spot where Earth and our solar system are today was just the edge of the Milky Way galaxy. Back then, there was no planet here, only a massive, floating cloud. A cloud filled with nothing but dust and gases. But what happened inside that cloud? That turned it into a planet that we now call our home? That mysterious cloud of dust and gases is called a molecular cloud. Inside it were tiny dust particles, made of sand, silicon, and various metallic elements. This cloud didn't just appear randomly. It was born from the deaths of ancient stars. In the early universe, many stars burned through all their fuel, and when they had nothing left to burn, they exploded. With those explosions, the remnants, the particles, were scattered all across the universe. These clouds didn't look like the ones we see in the sky. No, they were strange and mysterious. They were captured with the help of the Hubble Space Telescope, and unbelievably, this cloud was massive. It stretched across 100 light years. To give you perspective, if light started traveling from one corner of this cloud, it would take 100 years just to reach For millions of years, this cosmic dance continued. Quiet, relentless, unstoppable. At the heart of a vast molecular cloud, something extraordinary was happening. The core grew denser, spun faster, heated up beyond imagination. And then, boom, a blazing sphere of nuclear fire ignited. Our sun was born, but the story didn't end there. The remaining gas and dust didn't just vanish. It began to swirl around this newborn star. This leftover cloud, chaotic and full of potential, held the ingredients for something far greater. The planets, the moons, even life itself. But how? How did lifeless dust become a living solar system? For centuries, that remained a mystery. It all started as a bold idea. In the 1700s, German philosopher Immanuel Kant and French scientist Pierre-Simon Laplace suggested that stars like our sun might form from these immense molecular clouds. But back then, it was pure theory. No evidence, no way to prove it. That changed in the early 20th century. By the 1920s and 50s, telescopes had grown more powerful. Yet the birth of stars still eluded direct observation. Then came the breakthrough. In the 1970s and 80s, radio and infrared telescopes allowed scientists to peer through thick clouds of dust. What they found inside was astonishing. New stars, forming in real time within molecular clouds. The theory was no longer just a theory, it was fact. And those leftover particles, they were starting to form planets. Still, one question lingered. How did it all begin? What kicked off the process? Surprisingly, the answer came, not from a telescope, but from an astronaut. In March 2003, aboard the International Space Station, Don Pettit ran a series of microgravity experiments. He played with water bubbles, dissolved rings, and spun salt inside a plastic bag. It seemed simple, but what happened next changed everything. Over time, the tiny salt particles began to cling to each other on their own. No force, no glue, just natural attraction in zero gravity. It was a revelation. In space, tiny particles are drawn to one another. Just like that, scientists realized this is how it starts. Inside a molecular cloud, dust and gas particles orbiting the sun begin sticking together, just like Pettit's salt grains. About 5 billion years ago, this same process unfolded in our solar nursery. Tiny clumps became larger and larger until one reached the size of a mountain, about 1 kilometer wide. At that point, gravity took over. The clump began pulling in everything nearby, like a cosmic vacuum cleaner. This gravitational snowball kept growing for 3 million years. And from this chaotic storm of dust and rock, 20 planets took shape, each finding its place in orbit around the newborn sun. The solar system was forming. Life could only begin if Earth cooled down. But before that could happen, it had to survive a deadly threat, solar storms. These violent bursts from the sun don't just damage electronics, they can wipe out atmospheres. Take Mars, for example. Solar storms destroyed any hope of life there. So how did Earth survive? The secret lies deep in Earth's core. When Earth first formed from a molecular cloud, it was a molten fireball. So hot that iron and nickel melted. Being heavy, they sank into the core. Geophysicists say that when molten iron spins rapidly, it generates a magnetic field. That's exactly what happened. Earth's spinning iron core created a powerful magnetosphere that protects us from solar radiation. But Earth still wasn't ready for life, until a planet the size of Mars smashed into it. This giant collision tilted Earth by 23.5 degrees, giving rise to seasons. Now the Earth experiences summers, winters, and rains, which support a diverse ecosystem. That same impact also formed the Moon, whose gravitational pull created ocean tides. Tides help circulate nutrients in the sea, critical for marine life. But here's the bigger question. Where did Earth's water come from? For a long time, this was a mystery. Then, in 2005, NASA sent the Deep Impact Probe to a comet named Tempel 1. It slammed a copper block into the comet. An analysis showed it was full of frozen water. This proved that comets carry water. But how did millions of them reach Earth? The answer? Jupiter. Its powerful gravity, near the asteroid belt, disturbed comet orbits, flinging icy bodies toward Earth. Geologists believe water arrived 500 million years after Earth's formation. How do we know? Thanks to a mineral called zircon, which only forms in water and contains uranium. By dating zircon, we found the first signs of water appeared around 4 billion years ago. From molten beginnings to a tilted axis to Jupiter's help in delivering water, Earth was finally ready for life. Its temperature dropped to around $100 a day. But one final piece was still missing: oxygen. Without it, life couldn't start. So now it's your turn. How did oxygen first appear in Earth's atmosphere? Let us know in the comments below. If you enjoyed this video from Very News USA, like, share, and support the channel. And show some love in the comments. Your support means the world to us. We'll see you in the next mind-blowing episode.